All right, so now we're going to look at using four rectangles. So we're going to say for this one, n equals 4. We have four rectangles. And so the first thing that we have to concern ourselves is, what are the x coordinates that I'm going to be putting my rectangles on? So this time, since I'm taking the interval from 0 to 2 and I'm breaking it into four pieces, the distance that I go each time is 1/2. So that means that my x coordinates are 1/2, 1, 3/2, and 2. All right. Now, these things have some names that are going to be useful as we go along. So we call these values the x sub i's. So this one's x sub 1, x sub 2, or x3, x4. And the first one at the beginning is x0, which in this case is 0, although it doesn't have to be. All right, so that's that. Now, the other thing that we're going to notice is, however long the interval is, together with how many rectangles, determines the width of the base of the rectangles. That base in this case is 1/2 every time. The base of the rectangles is always 1/2. So that's going to be nice to know. And that has a name. So we say delta x equals 1/2. And yeah, it's the same delta x as when we're talking about derivatives. It means a short distance on the x-axis, which in this case is going to be 1/2. And in fact, so you might notice some things like if I take the length of the interval, which is b minus a, all right, if this is a, this is b, so x sub 4 is generally going to be b, x sub 0 is generally going to be a, so we have an interval from a to b, b minus a over n, which in this case is 2 minus 0 over 4, equals 1/2, and that's the delta x, all right? So delta x is b minus a over n. That's something we're going to keep in mind. And it just means if I take an interval of a certain length, divide it into a certain number of pieces, that's going to tell me how wide the pieces are. All right, so that tells me the base of the rectangles. So the other thing I need to know is the height of the rectangles. So to know the height of each rectangle, what I have to do is know the function value, because the height of this first rectangle is whatever v of 1/2 is. All right, so what do I need to know? I need to know v of 1/2, I need to know v of 1, I need to know v of 3/2, and I need to know v of 2. So also really I need to know v of 0. And so some of these things I already knew. I already knew from previous work, v of 0 is 0, v of 1 is 1, v of 2 is 4. All right, and I know, so now I can figure out v of 1/2, which is going to be the height of this rectangle. V of 1/2 is just 1/2 squared, so that's 1/4. And v of 3/2 is going to be 3/2 squared, so that's going to be 9/4. All right, so I've got all this information that I can use. What the function values are at each point tells me the heights of the rectangles. I could label all these coordinates. I'm going to do that for this one, but we don't always have to do that. But just to sort of keep a perspective on what is really going on here. So this is the point 3/2, 9/4, and this up here is the point 20. All right. Now, when we label out, divvy up the x-axis with certain values, x sub 0 through x sub 4, which we will call x sub I sometimes, that has a name too. It's called a partition. It's a partition of the interval. All right. Now, let's go ahead and figure out, now we've really just thrown in some vocabulary and some additional observations about what things are constant, what things are not. Let's go ahead and find some of the rectangles. So I've only drawn in the upper rectangles, the ones that go over, the right rectangles. And we'll think later about what is it about this function that means that the right rectangles are above the function and the left ones are below. That's not always going to be the case. In this case it is. All right, so our sum is a1 plus a2 plus a3 plus a4. So now I know that this area of this rectangle is 1/2 times 1/4. So 1/2 times 1/4, plus my area of my second rectangle is 1/2 times 1. So 1/2 times 1, and then my A3 is 1/2 times 9/4, 1/2 times 9/4, and then my A4 is 1/2 times 2, 1/2 times 2. Now, as we're doing this, of course, we want to be looking for patterns that we can take advantage of over time, and we're going to notice, for example, that the first term factor of each term is 1/2, and it's the delta x, all right? And then the second factor of each term is the various values for v. All right, that's how we're going to sort of get this work a little more organized. All right, so here I have 1/8 plus 1/2 plus 9/8 plus 1. Let's see, that would be 10/8, which is 5/4. 5/4 plus 1/2 is 7/4. 7/4 plus 1 is 11/4. All right, so that equals 11/4. Also known as 2 3/4, right? 2 3/4. Yeah. Okay, that's the sum from the right. Now, let's look at the sum from the left, and we'll see we can take advantage of the fact that we've already done a lot of the work. The sum from the left and the sum from the right are not unrelated. So we have the 0 rectangle, that's going to be our A1 from below, and then we have this rectangle, which is going to be our A2 from below, and then this rectangle is going to be our A3 from, I'll put that up here, my A3 from below, and this rectangle is going to be my A4 from below. That's really from the left. Each of these, the rectangle touches the curve on the left of its particular interval. All right, so let's see what that sum from the left is. So sum from the left is going to be the green A1 plus A2 plus A3 plus A4, and that equals 1/2 times 0 plus 1/2 times 1/4, because the height of this rectangle is here, it's 1/4. 1/2 times 1/4 plus 1/2 times this height, which is 1. 1/2 times 1 plus 1/2 times this height, which is 9/4. Okay, so things that we want to notice in terms of a pattern, we still are starting with 1/2 every time, and just this time, see how you had here 1/4, 1, 9/4, 2? Now you have 1/4, 1, 9/4, right? 1/4, 1, 9/4. But now you're dropping the end interval and you're adding on the initial interval, right? So the same sequence of numbers. So these three in the middle are always the same, and you're either adding an additional interval to the beginning or an additional interval to the end. And but that first interval will not always be 0. In this case it is, just because the function starts at its y-intercept. All right, so this equals 0 plus 1/8 plus 1/2 plus 9/8, which is 10/8, 5/4 plus 1/2. I hope I didn't mess that up last time. Right, because this is 5/4 plus 1/2, which is 2/4, which is 7/4, right? So this equals 7/4, which is also 1 3/4. Hope I got that one right. I did, right? You're checking me, I hope. All right, so I'll check it in my next video, make sure it's right. All right, so doing fractions in my head, this probably should be fine, but all right. So here's what we now know about our magic area. It's between 1 3/4 and 2 3/4. So now we have a pretty tight interval on it. It's getting tighter. We're going to tighten it up again. We're going to do next n equals 8. And when we do n equals 8, the diagram, I'm going to still draw it, but it's going to get sort of cumbersome. And so what I want to look is there a way that I can tabulate the numbers without excessive reliance on the graph? The graph is great, but you're going to see how it's going to become cumbersome. All right, that's next. We're going to try n equals 8 next.